if I'm going to go after Eratosthenes, if I'm going to go after the foundation of globe science, I'm going to start at the beginning, and I'm going to tell the whole story. The story goes like this. Eratosthenes was in Alexandria, Egypt, and there was a well in Syene he read about. It was 500 miles south, where on the summer solstice, the sun shone directly to the bottom of the well with absolutely no shadow. He recognized the significance of this, measured the shadow angle of a stick in Alexandria on the same day, got approximately 7.2 degrees, divided that into 360 degrees, multiplied by the distance between the two cities, and calculated the Earth's circumference. So my question, how did he know where to place his stick? For this experiment to work, one measurement point needs to be at a geometrically significant location, specifically where the sun is directly overhead on the solstice. That location is the Tropic of Cancer. Not approximately, not close to it, exactly on it. But to know where the Tropic of Cancer is, you need to already understand the axial geometry of the Earth's surface. And to understand that geometry, you need the circumference, which is what the experiment is supposedly calculating. So you need the answer to set up the experiment that gives you the answer. That's circular reasoning. And when I pointed this out, I got a good response. Some good, some bad. But the response I got was that he didn't need to know where the equator was. He just needed to find the spot where the sun shines directly into the well on the solstice. And I agree. That's exactly right. But that spot is a geometrically defined point on the Earth's surface. Recognizing that the sun shining directly overhead on the solstice is significant, and knowing how to use that significance mathematically already assumes the axial geometry that you're trying to calculate. The circular reasoning stands. And my second question was, and this one is the one that globe defenders really don't want to answer. Is there a difference between a sphere and an oblate spheroid? Because the globe model doesn't claim the Earth is a perfect sphere. It claims that Earth is an oblate spheroid, flattened at the poles, bulging at the equator. The equatorial radius is 3,963 miles. The polar radius is 3,950 miles. The curvature is not uniform. It varies depending on where you are on the surface. Eratosthenes assumed perfectly uniform spherical curvature for his entire calculation. Every degree of arc producing the same angular change everywhere on the surface. But on a non-uniform oblate spheroid, that assumption is geometrically false. The degree of curvature per mile is different at the equator than at the poles. His angle, or angle-based calculation, produces a different answer depending on where exactly you take the measurement, because the surface curves differently at different latitudes on an oblate spheroid. So the conclusion is Eratosthenes calculated the circumference of a perfect sphere. The globe model says a perfect sphere doesn't exist. He calculated the circumference of something the model itself says isn't real. So that's two questions, no answers, but we can keep on going because it gets deeper. And I gotta go deeper so you really understand. Now I want to talk about the well, because nobody seems to want to ask the most obvious question of all. How did Eratosthenes find the well? He didn't discover the well himself. He read about it in a document, a second-hand written account of a phenomenon that conveniently demonstrated exactly what he needed to make his calculation work. So let's talk about what had to be true for that document to exist. First, a well had to be dug at a location precisely on the Tropic of Cancer. not near it, not approximately on it. A well shaft is vertical. For the sun to shine directly to the bottom with zero shadow, the alignment has to be essentially perfect. The margin of error is negligible. What are the odds a well gets dug accidentally at the exact geometric location? Second, someone had to be looking down into that well at the exact moment of the summer solstice. Not the day before, not the day after, not an hour later, an hour before, the exact moment the sun reaches its maximum northern declination and shines directly overhead. What are the odds someone is looking into the well at that exact moment? And third, that person had to notice the significance of what they were seeing. No shadow, sun directly overhead. They had to recognize that this was not an ordinary day and not an ordinary observation. Fourth, that person had to be literate in 240 BCE when literacy rates were a fraction of what they are now. Fifth, that literate person had to write about it, had to document the observation specifically enough that the geometric significance was preserved in the account. Sixth, that document had to survive. In an era before printing, before libraries as we know them, when documents were hand-copied and frequently lost. Seventh, that surviving document had to circulate widely enough to reach Alexandria. And eighth, Eratosthenes had to read it out of whatever documents were available to him. Ninth, he had to be located in a city that happened to be approximately 500 miles north, far enough to produce a measurable shadow angle, but close enough to measure the distance with his available technology. And 10th, he had to have the complete geometric framework already in place to recognize the significance of everything he was reading and to know exactly what calculation to perform. Every single one of these is a required link in the chain. Remove any one of them, just one, and now your story doesn't exist. In probability terms, these events don't add together. They multiply against each other. 10 unlikely events chained in sequence don't become more likely by being grouped together. They become exponentially less likely. At some point, coincidences stop being coincidences. At some point, you have to ask, was this a discovery? Or was this a story written to support a conclusion that already existed? To push a narrative. So I started with two questions. How did he know where to place the sticks? And does it matter that Earth is supposedly an oblate spheroid and not a perfect sphere? And then those two questions became 12 questions. And not a single one of them has been answered by anyone defending this experiment. Not with evidence, not with math, not with anything except confidence that the story must be true because it's been taught for 2,000 years. But I would argue it's only been taught for about 20 years. But Ptolemy's geocentric model was taught for 1,500 years also. Math working doesn't prove which model is true, and a story being old doesn't make it accurate. I don't need to tell you what to believe, I just need you to ask the questions. Because the questions are the science. This is how science works. You don't just take what they give you and say, okay, that must be it. You have to actually use your head. You have to actually think. You know? And when we're getting these stories crafted that just seem so perfect, just too good to be true, how did this possibly happen? How did all these coincidences multiply together? And they just so happen to support this wonderful narrative that they want everybody to believe, which is why they've been forcing it to us since we were little babies. Even though there's not one exclusive proof that proves the globe. Not one. Every single scientific experiment has supported that the Earth is a level, stationary, topographical, dielectric plane. Every single one.